Right, we're going to talk about law of sines. We're going to be working with case 2, which is called the ambiguous case, because when you're given two sides and the angle opposite one of those sides, we're given a situation where we're not entirely sure what we're working with. If you remember from geometry, that would be the situation of side-side angle or angle side-side, and that was not a proof of congruent triangles. So when we're using it with the law of sines, having sides and one angle opposite, that causes a problem for us. Okay, so there's three possibilities. You either have no solution, you'll have one solution, or two solutions. In this video, we are going to talk about what happens, how you know if you have no solution. Now, there are ways to tell before you start calculating whether or not you will have a solution. Okay, you will have no solution if A is less than B times the sine of A. Now remember, you're given two sides in the opposite angle. So what we're saying here is you're given sides A and B and the angle A, okay, the angle opposite A. Not only will they give you those letters, okay, so what we mean by this, okay, capital A is going to be the angle you're given.
Lowercase a indicates the side opposite that angle, and lowercase b is whatever other side you're given. So what you want to do is find b times the sine of a, and if you don't want to do this, it's okay, because at some point in the solution you'll notice that there's an error and that there's no solution. This is just a way you can tell right from the beginning before you even start solving. If b times the sine of a is bigger than a, then it'll be no solution. If it's an obtuse angle and all you know is that the other side is bigger than the one side opposite angle A, then you know there's no solution. And that's because, remember, in geometry we learned the biggest side is opposite the biggest angle. So if A is obtuse, it should be across from the biggest side. So if you have an obtuse angle and the side opposite is not the biggest, you know it's no solution. Alright, so we notice here we're given two sides and an angle. One of the sides is opposite our angle. And what they're saying is you could start right from the beginning and figure out what b times the sine of a would be. Again, this is your given angle times the side that's not across from that angle. So here's our triangle. We're going to sketch it out really fast. A is 110, lowercase a is 15, and b is 25. So again, what we want to do is find the side not opposite our angle, which in this case is 25, times the sine of our angle 110. This is our check that we're going to do to see if we even need to do any solving at all. When I do that, I get 23.5. And then what you want to do is compare that to the side that's opposite the angle, in this case 15. Okay, notice our A, which is 15, is less than our B sine A, which was 23.5. So automatically we know there's no solution and we could stop there. Now I know those are a lot of steps to remember. You could also go by the fact that A is obtuse, so the biggest side should be across from it, and it's not. Okay, so we also know it's no solution for that reason. If you don't want to test or you forget to test, that's totally okay. I'm going to show you what will happen and how you will know as you go through the solution so that you know that there's no solution. If we were to solve this triangle, how would we start? Well, we can't find missing angles B and C because we only have one of our angles in our triangle. What we'll have to do instead is use the law of sines. We have A and capital A, so we can use A sine A to find the missing parts. We know B, so we'll start finding our angle B. Put in the parts we know. We know A is 15 over the sine of angle A, which was 110, equals B. And we know B is 25, so we have 25 over sine B. And we cross multiply. So we get 15 times sine b equals 25 times the sine of 110. Divide both sides by 15. And I get the sine of b equals 25 times the sine of 110 over 15. Now if I calculate this, 25 times sine 110 divided by 15, I get that the sine of b is equal to 1.566. Now right now you might go, oh wait a minute, we learned that a sine can never be greater than 1, so it must be no solution. If you miss that and you keep going, what would we do? Well, we have sine, so we take the arc sine or inverse sine of both sides to solve for b. So if you missed all the warning signs so far, it's okay because we have one more chance to catch that there's no solution here. If we did the inverse sine of 1.566 in our calculator, we get an error. And we have to go, okay, so this isn't possible. And we know it's no solution. Of course, always go back and double check your work to make sure you didn't make a mistake somewhere. But here are 3 different ways you can tell there's no solution. The first is to run the test beforehand. But if you don't run the test and you're solving and you get that the sine is equal to a number bigger than 1, then you know there's no solution. And if you keep trying to solve from there, you'll get an error on your calculator, and so you'll know it's no solution. We're going to do another one. So we'll go through all 3 ways again. Again, this is your options. Okay, whatever you prefer is going to work out. Okay, again, we're dealing with case 2, where we have 2 sides and the angle opposite one of those 2 sides. All right, let's use the law of sines. I'm going to set up my figure, A, B, and C, and the sides opposite those, little a, little b, and little c. A is 30 degrees, so that makes little a is 7. Our small c is 16, should be across from our angle C. Now if we decide to run the test to determine how many solutions there might be, okay, we take the non-opposite side, which is 16, or C, times the sine of our angle, A. We need to check that and see what we get. So we get 16 times the sine of 30, and that gives me 8. The rule was that if that's bigger than our side A, then it's no solution, and notice it is. 8 is bigger than 7. So I would know right away that there's no solution and I don't need to go any further. Double check and make sure you didn't make an error first, but that would be the test. Now if you decide not to use the test, we can go ahead and use the law of sines. Again, we're given A and angle A. We have those 2 pieces, so I know I want to use those. And I'll have to start by finding angle C because I'm given C. I put in my information. I have 7 over the sine of 30 equals C, which was 16, over the sine of C. We want to solve for C, so first we'll cross multiply to get C out of the denominator, and we get 7 times the sine of C, which equals 16 times the sine of 30. Still trying to get C alone, so we divide both sides by 7. Now I have that the sine of C equals 16 times the sine of 30 divided by 7. I'm going to go ahead and calculate that. That gives me 8 over 7, or sine C equals 1.142857. At this point you might be able to say, well, the sine can't be bigger than 1, so I know this is no solution. Okay, so these are the 3 places you can check at the beginning, you can get to the bottom and find out that, oh, sine is equal to something greater than 1, so it's no solution. Or if you don't notice there, again, and you keep trying, we would do the arc sine of both sides to try to solve this. And we get that angle C, and you put in your calculator the inverse sine of 1.142857, and your calculator is going to say error. Okay? And so at that point then you would know, once again, no solution. So I'm not saying you have to go that far. I'm not saying you have to use any specific of these three options to know it's no solution. Any of these ways are just fine. Okay, but if you have two sides and one opposite angle, it could be no solution.